If you think you know what this is, you're most likely wrong. This does look like an Arduino Uno, but it's not. It's actually the latest board from Arduino, and it's called the Arduino UNO Q, and it's completely different from a classic Arduino, and it has so many new features and capability which will revolutionize the way you invent with electronics. So in this video, I'm going to explain to you what's new with this board and what you can do with it, and I'll also show you how you set it up and you use it. So follow along on this journey. So my name is Massimo, I'm the co-founder of Arduino, but I'm very excited to do this video because this is the first Arduino product which I had nothing to do with. So it's good to use something that the engineers and the designers and the software people at Arduino have built as an external user. So it's kind of a strange condition for me, but I love it. So let's have a look a little bit at what are the features of this board. So here's a better picture of the Arduino UNO Q. You can see it's quite dense in terms of hardware, and it's got a lot more chips than the classic Arduino UNO Q because this board has two brains. So the classic Arduino is a simple 8-bit microcontroller. This board, it's actually a Linux machine. It actually has two processors. Compared to a classic Linux machine, this has a processor that can run Linux and a microcontroller that can actually run Arduino code. So you kind of get the best of both worlds. So the main processor is the Qualcomm Dragonwing QRB2210 quad-core Cortex A53 up to 2 GHz of clock, and it's got a Adreno 702 GPU, and it's running Debian Linux. The MCU on it, it's an STM32U585. It's a Cortex M33 which can run up to 160 MHz, 2 MB of flash, 786 KB of RAM, and it's also got a floating point acceleration unit, and it runs Arduino code on top of the Zephyr operating system, while the Dragonwing processor is running Debian Linux. So as I said, you get best of both worlds. So the classic Arduino Uno, as I mentioned, is just a simple microcontroller. It runs straight C++ code compiled to a binary file on the microcontroller at 16 MHz. So any 8-bit microcontroller is a bit limited in terms of their computing power, and also the 16 MHz, it's kind of limited nowadays. It's great, it solved problems for a lot of people, but it's, kind of old school right now. The Arduino UNO Q has an entire Linux machine that boots and then connects to the microcontroller, so you can use both sides of the board to your advantage. So having a full Linux machine means that you can actually run the code that you will run on your machine, on your laptop. So you can run advanced Python code, you can run the full Python 3 point something or any other language that runs on a Linux machine. But a lot of Linux machines have this limitation that whenever they have to do very low-level tasks that needs to be done very precisely, like for example, controlling the stepper motors on a 3D printer, they usually are not really good at these real-time tasks. So the microcontroller comes in and saves the day because a microcontroller is really good at running these very time-sensitive tasks. So for example, if you were to build your own 3D printer with the Arduino UNO Q, you could be running a firmware on the microcontroller which drives all the motors and the extruder and everything else, and reads sensors, does a bunch of other things in real time, and it communicates with the Linux machine where you can actually run maybe the software that slices the model or the software that actually decides how to move the motors in the end to print the object you're trying to print. So this combination application is pretty amazing because this also gives you, you can put a web interface on it. You can live stream a web camera. So there's a bunch of things you can do, all packaged in the size of a classic Arduino, which is pretty amazing, I have to say. One caveat is that the classic Arduino Uno runs at 5 volts, and this microcontroller on the Arduino UNO Q is actually running at 3.3 volts. So you gotta keep that in mind. But apart from that, once you program the microcontroller, it's pretty much like one of the many Arduinos out there. Now, let's see a few more things about this board. This board is great for educators who are trying to teach, for example, AI. You can even run language models on this. Very tiny ones, but you can. It does computer vision. There's a bunch of examples that I'll show you later that allow you to run computer vision projects on this board. You can use it to teach programming. You will see it has a number of different features that make it very useful for people doing robotics, people who do 3D printing, for example, controlling different kind of machinery, doing Internet of Things applications, and it's different from a classic Arduino, so it requires a little bit more effort to be understood and to learn from it. But once you grasp it, you get so much more than a classic microcontroller. Here you can see a diagram of what's on the board. So on the left, you see the top view of the board. There is a Wi-Fi 5 and Bluetooth Low Energy 5.1 module on the left. The main processor is in the middle, QRB2210. Then there is RAM. This board is available in 2 versions, a 2 GB and a 4 GB RAM version, which, if you're trying to run some more complex algorithm or doing some kind of small-sized AI application, the 4 gig might be better for you. So let's continue looking at it. So there is this Qualcomm PM4125. That's a PMIC. That's the chip that normally manages the power on the board, but it does a bunch of other services for the processor. And throughout this series of videos, we'll look at what this chip actually does on top of just managing the power. There's also the ANX7625. It's a MIPI DSI to USB-C bridge. What that does, it takes the video image from the processor and sends it to the USB-C. So it basically interfaces the USB port with different services on the processor. On the back, you see the microcontroller, you see the onboard flash memory, and the 2 big connector, JMedia and JMISC, which we'll explain a little bit later what they do, but they allow, different expansion boards to be created and connected to the back of this Arduino UNO Q. So how do you power the Arduino UNO Q? Well, the first thing, you can use a USB cable. It needs to be able to deliver 3 amp tops in terms of current, because once everything is running here, it uses a little bit of power. You can power it through the 5 volt pin, or you can power it from the V-in pin. So probably V-in is a little bit more safer, and it can be powered all the way up to 24 volts, which is going to be useful in certain more kind of industrial application where the 24 volts is the standard power supply. But how do you use Arduino UNO Q? It's got 2 modes. Mode number 1, you connect it to your computer as usual, and then there's a number of software that Arduino provides that you can use to control the board. And then there's another mode which is interesting, because the Arduino UNO Q, it's actually a standalone computer. So if you connect a USB-C hub to this board, and you connect a keyboard, a mouse, and a screen, you can use it as a small computer. It's running a lightweight desktop Linux, so you can actually launch different kind of application and use it as a tiny PC. It's not exactly super fast in this mode, but it's useful. You can actually do things with it. So these are the 2 main modes of use of the board. So how do you program the Arduino UNO Q? There are 3 ways to do that. The first way is you use the Arduino IDE. The Arduino IDE lets you program the microcontroller on board of this thing so that you can run Arduino code on it. This only allows you to program the microcontroller on this thing, so it doesn't allow you to program the Linux side, but that's like a class. If you are used to that way of programming an Arduino, this will work for you. Then Arduino developed a new piece of software which is quite sophisticated called Arduino App Lab, and this is an application that you can download on your computer, or you can even use from inside the board if you connect a mouse and a keyboard. And it allows you to set up a new board. It allows you to see different examples of applications that you can run on the board. It shows you the apps that are on your board. Enables this mode of programming, which is quite innovative, where you have this concept of an application which is made of Python code, runs on the Linux side, and then microcontroller code, which runs on the microcontroller, and the two sides can talk to each other through something called the Arduino router. So you can actually get application where the microcontroller talks to the Linux side and they cooperate depending on the application. And inside App Lab, there's a ton of examples of different kind that you can explore yourself. And you can use the Arduino command line. As we'll see later, if you install ADB, which is the tool that normally it's used to manage Android phones from a computer, if you're a developer, with ADB, you can actually log on to the board from a command line. So it's almost like, if you're familiar with this, it's like SSH, but you just plug a cable and you do ADB shell and you're in. So you can do almost everything you do with these visual tools that I mentioned from inside the board, from the command line. And that's pretty powerful, because if you're used to the Linux command line, then it's probably faster for you to use this as opposed to the visual environment. So let's talk a little bit more about Arduino App Lab. As I mentioned, it's a software that when you launch it, it will look on the network and try to find if there are already configured Arduino UNO Q, and you can click on them and you can connect to them remotely, or it will look for an Arduino connected to the USB cable, and it will allow you to configure it. If it's the first time the App Lab sees your Arduino UNO Q, it will go through the process of configuring it, downloading the very latest version of the software, and getting it ready for you to program. It will show you how to program it. There's a Python IDE included. There's an Arduino IDE included. So, and one of the things that we will touch more later is this concept of Arduino bricks. So basically, Arduino created these Python libraries, these modules they call bricks, and each one of them takes care of a piece of functionality in your Arduino UNO Q. So when you're programming in Python, and for example, you want to access the camera, there's a brick for that. If you want to do other activities, for every kind of activity, there is a brick that you can bring in your code and it will accelerate. So for example, there is a brick that allows you to connect to a large language model on the cloud. So your application can basically make queries and receive data from an LLM. If you want to see some cool examples on how to use that, go on YouTube on the Supermoderno channel. You will find a video that shows a class that I've been teaching at the Copenhagen Institute of Interaction Design, where with my students and my friend Jose Chavarria as a co-teacher, we worked on the idea of building objects that have no screen, no mouse, no touch interface, that actually are made intelligent through the connection to a large language model. So you can see a bunch of examples of that in that particular video. So this is the kind of environment that you have available when you use Arduino App Lab. I think this is, and I digress a little bit, but it's very in line with the Arduino philosophy. So the Arduino philosophy is to build tools that will allow you to be productive from day one. Look, there's a ton of Linux boards in the world. There's a ton of things that say they are similar to this. But there's a lot of cheap Linux machines that come from Asia, and sometimes they don't even have like a ready-to-go software. You have to scour the internet looking for whatever operating system you need to put on it. Or there are other boards that come with software, but they're basically bare. They don't do anything because they're all designed for people who know what Linux is and they know what they can get out of it. But The Arduino philosophy is, okay, Linux is a very powerful tool, but it's kind of complex for many people. So there are software tools, software libraries, applications. They will basically make it incredibly easy for a beginner to use all the functionality of the Linux machine without actually knowing very much about Linux. Actually, you can use this thing probably without knowing what Linux is. And in Arduino has done that before. Like many years ago, we made this thing called the Arduino UNO, where there was a small Linux machine and a microcontroller. And again, the idea there was the Linux machine is helping the microcontroller do incredible things, but you don't see it unless you are an expert and you want to see it. So I think this Arduino philosophy applied to Linux and a product like this gives you something that's very powerful, but you can use even if you don't know anything about Linux, so you can concentrate on the amazing things that you can do as opposed to where the hell do I find a working kernel for this piece of hardware. So as I mentioned, there are a couple of ways of using App Lab. You can download it on your computer and we'll do that in a few minutes. Or you can run it from inside the Arduino UNO Q, which is kind of slow, I have to admit, to be honest, but it's there and it works. Or it's interesting how App Lab on your computer can actually, as I said, discover the Arduino UNO Qs on the network and manage them remotely, which is quite practical, also because you can give a different name to every Arduino UNO Q. And this is also useful in an educational setting where, sometimes when we teach with Arduinos with Wi-Fi, it's kind of a nightmare to understand which Arduino is which on the network. But if you configure all the Qs with their own name and then they all show up on your app, you can click on a specific one and manage it remotely. So what kind of inputs and outputs are available for you? So there are the classic Arduino connectors. You can actually use any Arduino shield as long as they are compatible with 3.3 volts board. There are some old Arduino shields that are designed to run on 5 volts, and actually inside they are designed in a way that if you plug them on an Arduino that doesn't run at 5 volts, they create a short circuit. Many years ago, we added this pin called IORF that was supposed to tell the shield, hey, this board is 3.3 volt, adapt yourself. Not many people used it, and it's a pity because it would have made life simpler for a lot of people. But, if you have a shield that's compatible with the 3.3 volt board, and there's now many, you can use it with this. So, imagine motor drivers or all sorts of exotic sensing shields, you can use it. Again, on YouTube, you can find a video that I made of developing the ultimate smart lamp, where we built a shield that contained a bunch of environmental sensors and the interface to LEDs and an e-paper screen, and we plugged it on top, and that's what basically powered the lamp. Another interesting thing is that the Arduino UNO Q contains a connector that's compatible with what somebody calls the QUIC system. Arduino calls it the Modulino system. Basically what it is, it's a 4-wire I2C connection that you can plug in modules made by multiple different people. So Arduino makes Modulino, particularly smart modules that accelerate the hardware development. There are similar modules from SparkFun, Adafruit, and a bunch of other manufacturers. So with one single connection, you can daisy chain a bunch of different modules and you can build a very cool application. It also has an LED matrix, which is driven by the microcontroller on board. So when you boot the computer, I'll show you later, when you boot the Arduino, you'll see the infinite symbol, and then it will turn into a heart to tell you that the board is ready. But you can also use it from your code to display things in different ways. As I mentioned already, at the back there is JMISC and JMedia, which can be used to connect different modules. At the moment, Arduino has announced this thing called the media carrier that allows you to connect 2 cameras and a DSI screen, and also it has a jack for audio input, audio output, headphones. So you can develop a bunch of robotic and multimedia applications with this carrier. And in one of the videos on this series, I will show you how to use the media carrier. So we are going to set up our Arduino UNO Q. So now we are going to unbox my Arduino UNO Q. This is a 4 GB RAM model, which I got from Arduino. So thank you, shout out to the Arduino marketing team who shipped me this box. So we're gonna open the box now and pull out the board. The sticker is very strong, which is good. So when you open the box, what you get is the usual leaflet that comes with every Arduino board. There's a small leaflet that tells you where to find all the documentation for the Arduino UNO Q. The box is kind of the classic cardboard box that's used in a bunch of other Arduino products. It still contains the old graphic design. There is 2 resistors holding hands, building a heart, and it says, open source is love. Which it's a beautiful message. And let's move this aside. So here we have our anti-static bag. Let's open it up. Here's the board. So the Arduino UNO Q. I'm going to bring the keyboard in because I will need to press some buttons, and I will need a mouse, and I will need a cable that goes into my computer. So let's grab a cable, a USB cable. As you can see, this USB cable is a bit chunky because this board needs quite a bit of power, and if you want to connect this, for example, to a USB-C hub, it's quite important that you use very high quality cable, because otherwise not all the wires are going to be connected, and when you try to plug it to the USB hub or to the monitor, nothing is going to happen. So get a nice chunky cable. We're gonna plug the board, and you can see here the animation. The board is booting. At the moment, App Lab can see the Home Assistant Arduino UNO Q because this is the one that runs the whole place. So if you go to the Super Moderno YouTube channel, you can find a video where I explained how to run Home Assistant on this board, and you can use it to automate your office or your home. Okay, now the Arduino UNO Q is ready. I have a small caveat that I need to discuss. If you're running Linux, you have to run this code that you see on the screen in order to add the Arduino UNO Q to your UDEV rules, so that when you plug the board in, it's recognized by the system. Otherwise, you will always have to run your code as root, and it's a pain in the ass. This only applies to Linux, so that's it. So App Lab, let's click on the button. Now I can configure my board. So let's pick a name for the board. I will call the board Arduina, because in Italian electronic boards are female, so I'm going to call it Arduina. So now I'm going to have to connect to the Wi-Fi, and I'm going to use a password that's not amazing, but just for example purposes is password. But please pick a strong password, otherwise somebody can connect to your network, see your Arduino UNO Q, connect to it, type password, and kind of hack into your board. So use a strong password. So now here's come a little bit of a boring part. When the board is manufactured, the operating system is stored on a memory on the PCB. And when you connect it to the network through App Lab the first time, it's going to go online and check if any of the software has been updated. And this basically causes the board to start updating all the things that have been improved in the meantime. And this can take quite a lot. So I'm going to start install updates. And so I'm going to take a couple of minutes just to discuss why is it good to have the memories mounted on the PCB and not using an SD card. So on Linux boards, clearly the SD cards is practical. I just write it on my computer, I plugged it in, it's very practical. I can swap SD card, absolutely. But in certain application, it's kind of annoying because the connector can fail. So in certain applications where there are temperature variation, vibration, a number of other conditions, the SD card connector can fail and your board will reset. If the operating system is stored on a memory which is mounted on the PCB, then it's very reliable and it cannot be, let's say, reset because the SD card is not making good contact anymore. So this is actually quite good. The other advantage is that you turn on the board and you have your operating system on it, while with other Linux boards, you have to go online, search for the operating system, download it, download an app. Normally you use Balena Etcher or something else to write the image onto an SD card. And also depending on which SD card you buy, you get good and bad results. Some cheap SD cards die after a minute and a half. So a nice flash memory soldered on your PCB, it's a very reliable, very robust way of storing the operating system. So I'm glad Arduino chose to do it this way. And this platform is constantly evolving. And you will see later there's a bunch of different features related to AI that are available on it. So it's pretty amazing. So this is downloaded and updated all the Linux packages. Now is kind of updating the Arduino packages, and it's also updating the actual Arduino libraries. So when you compile the code that goes onto the microcontroller, then you use libraries, and so it's updating the onboard definitions and libraries. And okay, it is done updating, and we can restart App Lab because the software is the latest version and the board has been restarted. And there you go. This is Arduino App Lab in all its glory. Here you can see my apps. It's empty because I have no applications installed. It's the examples that I can run. It's quite a lot of them. Then here it's a catalog of bricks. So I'm not going to go into detail right now, but just to give you an example, this brick connects to the Arduino cloud. So if you have regular Arduinos with Wi-Fi connected to the Arduino cloud, your Arduino UNO Q can also participate in that cloud. It's pretty amazing. So for example, this is an audio classification brick. You can see there's a little icon that says AI because this is running an algorithm that can detect certain kind of sounds. In the example there, you can see that it has been trained to detect the glass breaking. So this brick looks for QR codes on the camera. So you see LLM connections, keyword spotting, image classification, database connections. So there's a ton of this. There's like a Telegram bot. So there's a lot. One of the interesting things that we'll use later is the web UI. So the web UI allows you to create an entire simple web interface using just 4 lines of code. You can get a web interface that you can connect with your phone or your computer to the Arduino UNO Q through Wi-Fi, and you can actually control different things. You will see it's interesting because if you have a sketch running on the Arduino microcontroller side and you have code running on the Python side over here, you can maybe even build like an interface where you move a slider on a web page and the signal goes through the router that we discussed before to the microcontroller, and the microcontroller can maybe control a lamp. So these are things you can do by taking advantage of the onboard bricks. There's a learn section where you can actually basically go through different classes and understanding what is the Arduino UNO Q, what's first, so all the things that we're doing in this series. Settings, it's quite complex, but you can set a bunch of different parameters. So here you can see that the system is updated. We can change the password. Remote access SSH that you see on the screen there is basically an indication that you can securely connect to the board using the SSH protocol, which will basically allow you to open an encrypted connection to the command line interface of the Arduino UNO Q. This is almost like if you have an Android phone and you go into the About phone, there's usually like a system information. You get a bunch of information. This is the equivalent, and I get to see my IP address, which means that I can connect externally. One thing that we will explore later is this button that says enable external carriers. I'll make a video about the media carrier and show how you can play audio from it, for example, or connect a camera. And the way we do that, we click that button and we specify from a menu that we have the media carrier. And in that case, we can say, hey, I will have a camera connected here and a screen connected here. And now it's kind of magic. You just say, I have a screen connected to the DSI connection. You connect the screen and boom, the desktop of your Linux machine shows up on the screen. So it's quite neat and very simple. If you click on account, you can specify your own Arduino cloud account. So you connect to the sort of Arduino infrastructure. Over here at the bottom, you can see that my board is called Arduino. It's an Arduino UNO Q. It's connected through USB. If I connect through Wi-Fi, there will be a different icon. At the bottom, it tells me all the different, basically, storage capability. So in this case, it says how much flash I have, and it says how much RAM I have. So for example, I'm using of 4 gigabytes, I'm basically using 500 megabytes of RAM right now, and the CPU is at 2% because the board is not doing very much. There is a symbol here that says connect to the board shell. If I press the button, then this window shows up. And it says I am the user Arduino on the board Arduino. If I type ls, which is the classic Linux, Unix command to see files, I can see the content of the board. We're not going to go through the command line right now because it's kind of an advanced topic, but here's a very simple way to just click the button and drop into the command line of your Arduino UNO Q. Let's do exit for now and press the enter button. So let's go to examples and run one example and then that's it. So I'm not going to jump too far ahead, but one interesting thing about the Arduino UNO Q is that on the Linux side, it's running a software called Docker. That was originally designed to partition big enterprise applications into what they call containers. So each application thinks they're running in their own little special Linux, but they're not running on their own computer, but they're just running on these containers on a bigger computer. Now the Arduino UNO Q is powerful enough that you can run containers over here. And the advantage of containers is also that your application runs in its own environment with the specific version of everything that it needs, and it's not interfering with the rest of the operating system. So we can have multiple applications running on the machine, maybe using different languages and different versions of libraries, because, each one is in a container. So let's click on an example, which is the simple blink an LED. Okay, blink an LED is the classic getting started from Arduino. You can see on the diagram on the screen that you have the Arduino board, the Linux machine, they're all connected. You see those wires is because the serial port on the microcontroller is connected to one of the serial ports on the Linux machine, and then the sort of Arduino side is connected to an LED. The example shows a simple blinking LED application. The Python script runs a continuous loop that toggles the LED. So the interesting thing here is that we can see on the left there is assets folder, which basically only contains the documentation, the images from the documentation. There is a Python folder where you can see a very simple Python program where basically this code just keeps running and tell the Arduino to change the LED state. So it's using bridge. You can see here that when you say bridge call, and there is between quotes, there is the name of a function, what happens is that the Python will send a message to the microcontroller. And if you specify the name of a function, if that function exists on the Arduino side, it will be called. So you can basically call functions that you wrote in C++ on the microcontroller like there were functions in Python, and you can also do kind of the opposite on the microcontroller towards the Linux one. Then here you can see sketch.ino has one function called set LED state. So every time it gets a Boolean, it will turn on and off the LED. So the sketch is simple. It just defines that the built-in LED is an output. It will start the bridge and tell the bridge, hey, set LED state is this function here, provide it to the Linux side. And then there is a function that just responds to the messages coming from the Linux side. So it's incredibly practical. Compared to running your own protocol, it's kind of a nightmare to do it. But this is out of the box. You just run it. There is a couple of YAML files here. This one is just, for example, a file that you would use with the Arduino CLI. So it defines which platform this sketch is meant to be compiled with. But you can do also more creative things with the YAML files. I'll explain to you later on. And also this app.yaml basically says this is the name of the application, this is the icon, this is the description. So the only thing that I can do is, well, I can press the run button and it will just go through the whole thing and make it work. Or I can basically press the other button and I will copy the application and edit it. So if I want to start from this example and make my own application, I press the second button. If I just want to run it, I press this button and I just want to run it. So I'm going to press the button. This is going to do a couple of things. Behind the scenes, it's going to take the Arduino code that I have in my sketch folder. It's going to compile it internally and it's going to program itself, which is pretty nifty, you gotta admit. And then after that's done, it will package up a container using the Python code and it will run it. Now we can see that the container has been run. And if you look at the camera here, you will be able to see, now it's gonna focus at some point, that the red LED is blinking. So our first application is running. This is amazing. This is a small summary of all the LEDs that you have on the board. So there are two RGB LEDs that are controlled by the microcontroller. So you can see here the names they have in the Arduino code. And then there are two RGB LEDs that are connected to the MPU. So MPU is essentially the Linux processor, while MCU is the microcontroller that runs Arduino. So you can see that the LED number one, it's called user. So it means it's available for user code. And then the second one is basically assigned to the system. So if the red comes on, that means panic. That means it's not good. Something bad happened. If you get the green signal, that's just the VLAN, so it's the wireless LAN operating. And then the blue is the Bluetooth. The image also shows where you can find in the operating system, basically the path that allows you to control this from your scripts. So we're gonna stop here for now. We have our beautiful Arduino UNO Q set up. You know a little bit about the feature of the board. You know how different and more powerful it is than an regular Arduino Uno. The combo of microcontroller plus Linux machine, it's incredibly powerful. Like, I know a lot of people who build application just by taking an Arduino and connecting it to a Linux board because they need both worlds. And I've had feedback from multiple people saying, oh my God, this is amazing. Finally, I have everything in one board. I think the platform has come along well. It was a bit rough around the edges when it got launched, but in the meantime, the Arduino team has done a great job at improving the code and improving the operating system. So it is a board that if you invest a little bit of energy to learn, you will step up massively in your innovation, inventing, in your prototyping process. So we're gonna stop here. Thank you very much for watching. I encourage you to go to the YouTube channel of Supermoderno to look at all the different applications. We already posted about the Arduino UNO Q. There's going to be multiple videos in this series, so we're going to guide you through all the different things you can do with the Arduino UNO Q, but let's start with this one. Thank you for watching. This is the first video in a series. We're going to show you everything that you can do with the board. If you invest the energy in learning about this board, your prototyping game, your innovation game will step up a lot and you'll be able to build amazing things. Follow us, look at the next videos. You're gonna learn everything about this board. Thank you very much.